Hello and welcome to a new video. This is for Algebra 1. We're in our 7th unit on polynomials. This is lesson 2, which is about adding and subtracting polynomials. The good old days of adding and subtracting when things were simple. Well, now we're going to do it, but like with x's, so fun stuff. Just like we can add and subtract regular numbers, we can also add and subtract polynomials. We'll also be able to multiply them and divide them. Don't worry, those will happen as well. The most important thing to remember as we're talking about adding and subtracting polynomials will be that we're only allowed to actually put like terms together. We can't just add anything together. What I mean by that is we've got two situations here. One is like terms and one is not. So like terms is whenever they both have x cubes, or both have x squareds, or both have x's, or both are regular numbers. Not like terms would be if we have just x cubed, x squared, x, and then a number. You can't combine those because we don't know what x is. So when we say 3x cubed plus 5x cubed, we're saying that we now have basically 8x cubes. And so how this works kind of is we're saying, hey, I've got an x cubed, and an x cubed, right? That's what 3x cubed means. And then 5x cubed means I have x cubed plus x cubed plus x cubed plus x cubed plus x cubed. So there I have 5x cubes. So when I add those together, I now have 8x cubes. That is different from what we just went over really recently, where we talked about multiplying x cubes together, right? That there, because we're multiplying x cubed and x cubed together, we actually add their exponents and get x to the 6th. So I'm hoping just by pointing this out, you can see the difference between these two situations. When I say 3x cubed plus 5x cubed, I end up with 8x cubed. Just like if you had 3 apples plus 5 apples, you'd end up with 8 apples. But when we have things that don't have the same number of x's, so 2x cubed has 2xxx, and then minus 4x squared has minus 4xx. Those don't have the same number of x's, so we can't combine them. Now there's two basic ways that we can do this. The way that I like better, at least initially whenever we're doing it, is to line things up vertically, because it's going to feel really similar to what we do when we add normal numbers. If I have this really long polynomial in parentheses plus this other polynomial in parentheses, those parentheses are just to show us the idea of like we're adding two polynomials together, and they don't really matter in this case, because if we are adding these, then we can just look for like terms. So what I'm going to do is I'm going to write the second parentheses underneath the first parentheses, but I'm going to do that in such a way that the like terms match up. So for instance, 2x should go under 5x, or negative 5x. Negative 7 should go under this plus 8. 3x squared goes under this x squared, and negative 4x cubed goes under this negative 4x cubed. And what's great about writing it this way then is that we can tell what has like terms and what doesn't, because the second parentheses didn't have any sort of x to the 4th, so we're just going to drop it down. And unlike with normal addition, we can actually do this from left to right because there's not any sort of carrying that happens like happens with numbers, so it's fine to do it left to right. Negative 4x cubed minus 4x cubed would be negative 8x cubed, because remember, two negatives added together make something more negative. 7x squared plus 3x squared plus equals plus 10x squared. My squared kind of came into my plus here. It looks weird. Negative 5x plus 2x is negative 3x. Plus 8 minus 7 is plus 1. So this is one way you'll see people show their work. The other way is basically, I think writing out the horizontal format is actually kind of ridiculous, because what they do is they have you write them next to each other, like the negative 4x cubed and the negative 4x cubed, just rewrite them but next to each other. Instead, I feel like what you'll see is that once you're getting the hang of this, you'll actually go through and be able to do it kind of in your head. And so you'll say, okay, there's only a single x to the 4th, so it just stays the same. Okay, let me look for, my next set of like things, or let me look for like things. So this one and this one. Okay, let me add those together in my head and get this. Let's do the x squareds. And so you'll actually find, once you get the hang of this, and it might happen pretty quickly, it might take a while, that you can actually just kind of do this in your head by going through and saying, okay, what matches up? And the key thing here is to make sure that you get everything, so you can mark things out after you add them if that will help. It's nice to put it in standard form because it makes it easier for you to grade or for your teacher to grade. And also it helps you keep track, because if I am looking at what are my fourth powers, what are my third powers, what are my squareds, what are my x's, what are my numbers, then I'm less likely to accidentally skip over something. So that's the idea. And now we're just going to do some examples. So example 1, add or subtract is indicated. I know whether I'm adding or subtracting by what's in between them. So plus in between means addition. Here I'm simply gonna, put the like terms together, and actually these are both in standard form, which is nice. So if I write the second one underneath the first one, I can just say, okay, what is 3x squared plus 4x squared? And what's 7x minus 1x? And negative 5 plus 10. That means our answer here is 7x squared plus 6x plus 5. And that's it. We can't add anything else together because those aren't like terms. It is in standard form. So there we go. That's how it works. Now, subtraction is a little bit trickier because if I'm subtracting this whole second polynomial, what happens is every single part of this has to be subtracted. Now, that's true whenever we do normal subtraction. We are going to subtract both of these ones. We don't subtract a 1 but then add the other one. We just don't think of it as distributing because we didn't know what distributing was whenever we learned how to do it. So what I want to do here when I rewrite this, I want to actually change all of the signs. I want to say, let me change this to a minus, and this to a minus, and this to a plus, because then I can add instead of subtracting. Okay, so what we're going to do is we're going to minus 5a. We're going to minus 6, but because the 2a squared was already negative, if I subtract a negative, it actually means I'm going to add. And so now, because I've already changed the signs, I can now add like terms. So 4a squared plus 2a squared is 6a squared. Negative 7a minus 5a is negative 12a. And negative 2 minus 6 is negative 8. So this is our answer right here. That's pretty much it, right? We've got addition, subtraction. We're going to have to change the signs. But otherwise, there's not really much else that can happen here. So probably have a couple more examples to do. And this would be a good time for you to try working ahead of me and see if you've got the hang of it. So example 3, we're going to add. Now this first parentheses is shorter than the second parentheses, so I think we're going to end up with some extra terms here. So if I write the second one underneath the first one, I'm going to end up in trouble, right? Because there's not enough of the things. So it might be better for me to go ahead and write the first one underneath the second one, which I can do because addition can be done in any order. So I could write the 6x cubed right here and the minus 2 right here. And then I can rewrite this in standard form by saying, okay, what's the biggest exponent? The x cubed? Okay, so 13x cubed, and then plus 7x squared, and then 5 plus a negative 2 is plus 3. And that's our answer. Let's check out another one. Okay, now we're subtracting. So remember, we want to make everything in the second parentheses be subtracting what it is. So I'm going to subtract 3v, which means I'm going to put minus 3v. I'm going to subtract negative 8v squared, which means that I'm really going to add 8v squared. I'm going to subtract 8v cubed, so that means that I'm going to subtract 8v cubed. So that plus 8 doesn't have a like term. And as I add this together, if I want, I can start with v cubed and work my way down, and then it'll be in standard form. So that's this one right here, negative 12v cubed. And then our v squareds, so that's 11v squared. And then our v's, 2v minus 3v is negative 1v, or just negative v. And then the plus 8 didn't have a like term, so it just stays plus 8. This is in standard form. I subtracted each of the things, so this looks good to me. And that's the whole thing. So basically, you're going to hopefully find this to be pretty easy. you're just looking for like terms. One of the biggest issues is going to be remembering to actually subtract. Whenever it says subtract, to actually change all the signs in the second parentheses. That subtraction symbol, by the way, the reason it's only affecting the second parentheses is you can think of it like there's a -1 that we are distributing. And so when we do the distributive property, it only affects the thing right next to it. So since it's minus the second parentheses, it's affecting the second one. In order for us to distribute a negative for the first parentheses, there'd have to be something in front of the first parentheses. That's just kind of the way we do order of operations and how that works. So anyway, thanks for watching, and I will catch you in the next video. Please subscribe if you haven't already, and hit the thumbs up because you like me or the video or life, or just because you like, if you like anything ever, hit the like button. And hopefully not many of you are like angsty teenagers that don't like anything. All right, bye.